Good morning all. In the last class we introduced about alternating current, and today I am going to discuss about resistor only circuit or R only circuit. A resistor only circuit is connected to a voltage source of V is equal to Vm sin omega t. Resistor of value R is connected to a voltage source, AC voltage source. This is an AC voltage and this is a resistor. Okay, what we need to find is the current through the circuit. We know that voltage B is equal to Vm sin omega t, and we need to find the current. We know that the resistor is a device which obeys Ohm's law. Therefore, I is equal to V by R by Ohm's law. Therefore, we can write I is equal to Vm sin omega t by R, that is equal to I equal to, we can call Vm by R as Im, the maximum value of current, Im sin omega t. Okay, therefore this is the equation of current. This is the equation of current in a resistor only circuit, and this is the equation of voltage in a resistor only circuit. This is the phase of voltage, phase, that is equal to omega t. Here also phase is omega t. Therefore we can say voltage and current are in phase. In a resistor only circuit, voltage and current are in phase. Okay, let us try to draw the Phasor diagram. Let us try to draw the Phasor diagram. What is a Phasor diagram? Phasor diagram is a representation of a simpler representation of alternating voltage in terms of a rotating vector. What that is a phasor. In Phasor diagram representation, we can understand the relative phase difference between voltage and current. That is the importance of Phasor diagram representation. Okay. Phasor diagram. Let us take this as or this as V, and this angle is omega t. The current angle of voltage is omega t, and the angle of current is also omega t. Therefore we can draw like this. current. The magnitude of current can be the magnitude can be any magnitude according to the value of R. If R is greater than 1, magnitude of voltage will be greater than magnitude of current. If R is less than 1, magnitude of voltage will be less than the magnitude of current. Okay, that is this is the Phasor diagram representation of resistor only circuit. This is a diagram representation of R only circuit. Okay, this is about resistor only circuit. The most important thing is the starting point. Starting point of this derivation is it is not a derivation, but the starting point is Ohm's law. We can apply Ohm's law here. That is because resistor is a device which is obeying Ohm's law. In the case of inductor or in the case of capacitor, we cannot use Ohm's law because inductor and capacitor will not obey Ohm's law. That is not an ohmic component. The resistor is obeying Ohm's law. That is the pi cara is a linear function. That is why Ohm's law can be applied here. Okay, this is about resistor only circuit, and we can go to the power calculation, and let us look into the waveform. Okay, waveform of voltage and current. The waveform of voltage and current let us take this as voltage. This is voltage waveform. V omega t. Where omega is the angular frequency. T is the time, and V is the instantaneous voltage. V or I. Both are in the same axis. The value of I will be that means the voltage and current are in phase. Voltage and current are in phase. That is why we plotted a diagram like this. If voltage and current are in not out of phase, the diagram may look like this. Okay, this is not happening in the case of a this will not happen in the case of a resistor only circuit. In the resistor only circuit, the value of voltage and current are in phase. The maximum value occur at the same time and minimum value occur at the same time. This is 0, this is pi for a sine wave. This is 2 pi. The voltage or current will reach the maximum value at a 0 value at pi and 0 pi and 2 pi respectively. Okay, this is the waveform of a resistor only circuit, and let us calculate the waveform. Let us try to understand power. We know that in a resistor the power dissipation will be I square R. P is equal to I square R. In AC there is two half cycle, one is the positive and other is the negative, but this is I, but the waveform of I square may look like this. This is not exactly a sine wave, it is sine square. I square. I square is not I square is always a positive value, therefore power is always a positive value in a resistor only circuit. Okay. Therefore P is equal to I square R. Therefore I is equal to Im sin omega t. Im sin omega t square into R. That is equal to Im square R sin square omega t. This is at every point P instantaneous. To calculate the average value, we want to calculate the average value sin square omega t 0 to 2 pi over 1 period. We can take 0 to t also, 0 to 2 pi sin. Actually the limit is omega t is equal to 0 to 2 pi. When we take capital T period, the limit is t is equal to 0 to 2 pi. Okay. We can write t omega t. Omega t is the variable here. Therefore, Im square R by 2 pi into what is sine square theta. Sine square theta. What is the equation of sine square theta? Cos 2 theta is equal to 1 minus 2 sine square theta. Therefore, sine square theta is equal to sin square theta equal to 1 minus cos 2 theta by 2. Then we can write 1 minus cos 2 theta by 2. Sorry, not theta. Here is omega t. T omega t. Then we can write that is equal to im square r by 2 pi into, we can split the integral 1 by 2 into 1 by 2 into d omega t 0 to 2 pi d omega t plus im square r by 2 pi into what, cos 2 omega t by 2 d omega t. We know that the value of this integral is 0. That means the average value of cos 0 to 2 pi. The average value of cos over a period is 0, or for every positive value there exists a negative value of same magnitude. Therefore this integral will be 0. So we can write this as this integral alone equal to im square by 4 pi, this 2 into here, omega t 0 to 2 pi, that is equal to im square by im square r by 4 pi into 2 pi minus 0. 2 pi and 2 pi will cancel only. Therefore P average will be equal to, for a resistor only circuit, P average will be equal to im square r by 2. For a resistor only circuit, the average power will be equal to im square r by 2. Then we saw that P average is equal to im square r by 2 for a sine wave. We are going to define a new term which is the RMS value. We saw that the average value of an AC is 0. So we want to define something else for describing an AC signal. Therefore, this is the power dissipated in the resistor only circuit when an alternating current of peak value Im is flowing through the resistor. If in the case of DC, we can write, if DC is passing through the circuit, the dissipation will be I DC square into R. We know that the power is I square R. In the time DC, we can, this is a resistor, and when DC pass through the when IDC pass through the circuit, a power PV, the same power will dissipate. That means we can equate Im square R by 2 into as I dc square r. We can r and r will cancel, then im square by 2 is equal to I dc square. Taking square root both sides, we will get I dc is equal to im by root 2. We can call this IDC as IRMS or IM by, that is equal to IM by root 2. This is what the definition of RMS current. RMS current IM by root 2. That means this is a AC signal, and this is IM, and this is IM by root 2. IM by root 2 is the value of DC. That is, here in this diagram, the the yellow represents the RMS value. Actually, RMS is a DC value. RMS value is a DC value which is dissipating the same power in a resistor only circuit as the actual alternating current. I think the point is clear for you. This is about a resistor only circuit. In the next class, we can discuss inductor only circuit and capacitor only circuit. Okay, thank you for watching this video. Have a nice day.